Algebra can feel like this secret code, right? A jumble of letters and numbers that just doesn't make sense. Well, what if I told you it's just a language you haven't learned yet? In this explainer, we're going to crack that code together, learning its alphabet and grammar, piece by piece, until you're speaking it fluently.
So here's the game plan. It's a simple 4-step process. First, we'll meet the absolute basics, the building blocks. Then, we'll figure out how to give our creations proper names. From there, we'll see how they team up with addition and subtraction. And finally, we'll level up and tackle multiplication and division. Let's jump right in.
Sound familiar? Yeah, if you've ever felt that way, you are definitely not alone. But just think of it like this. You're just looking at a sentence written in a new language, and we're about to take that jumble and make it make perfect sense.
So, first things first. With any language, you can't just start writing novels, right? You gotta learn the alphabet first. So, let's meet the absolute basics of algebra.
Okay, our first letter in this new language is something called a constant. Think of it as the most reliable, dependable player on the team. It's a symbol with a fixed value, a number that never ever changes. It just is what it is.
And here's the best part. You already know these. You've been using them your whole life. We're talking about numbers like 8, 23, or even something like the square root of 5. If its value is locked in, totally set in stone, boom, it's a constant.
Next up, we've got the variable, and this is where things get really interesting. These are the wildcards, the shapeshifters of algebra. They're usually letters, and they're basically just placeholders for a number we don't know yet. And that flexibility is what makes them so incredibly powerful.
You'll see letters like X, Y, and Z all the time. The best way to think about them, they're like little mystery boxes. We might not have a clue what number is inside, but that doesn't stop us from moving the box around and working with it. And that, right there, is the magic of algebra.
So what happens when we start putting our constants and our variables together? Well, we get something called a term. A term can be just a plain old number, a single variable, or a mix of both. This is our first real solid building block.
And just look at the variety we can have. A term can be as simple as the number 7, or 5x. It can even be something that looks a little more complicated, like this fraction. They look so different, right? But believe it or not, every single one of these is just one single term.
Okay, now for the really cool part. Once you take these terms, our building blocks, and you start connecting them with plus or minus signs, you've done it. You've officially created an algebraic expression. You're not just holding the letters anymore, you're writing words and sentences.
All right, so we can build these expressions now. The next logical step, we need to learn what to call them. I mean, an architect knows the difference between a tiny little bungalow and a massive skyscraper, right? We need to do the same for our algebraic creations.
So, how do we name them? It's actually super simple. It all just comes down to counting the terms. If it has one term, it's a monomial. 2 terms, that's a binomial. Think bicycle for 2 wheels. 3 terms make a trinomial. And then you have polynomial, that's kind of the catch-all term for anything with 2 or more terms, since poly just means many.
Every polynomial also has something called a degree, which is kind of like its power level. And finding it is a really simple 2-step process, no sweat. First, you look at each term and add up the exponents, those little numbers above the variables. Then, you just find the biggest sum you got. That number is the degree of the whole polynomial. That's it. Easy as that.
Okay, we have built our expressions. We know what to call them. Now what? Well, now it's time to make them interact. We're going to start with the basics, adding and subtracting. This is all about how we combine these creations in a way that actually makes sense.
And this brings us to probably the single most important rule for adding and subtracting in algebra. I'm serious. If you remember one thing, remember this. You can only combine like terms. What does that mean? It means the terms have to have the exact same variable parts. Same letters, same exponents. The numbers in front, we call those coefficients. They can be totally different. That's fine. But the variable part has to be an exact, perfect match.
So, this slide shows you a couple of common ways to set up an addition problem. You can either stack your like terms vertically, just like you would with regular numbers, or you can group them side by side horizontally. Honestly, both methods get you the same answer. It's really just about which one feels cleaner and easier for you to use. Totally your preference.
Now, subtraction is almost the same, but it has one extra super critical step. After you line everything up, you have to, and this is critical, you have to change the sign of every single term you're subtracting. So a plus becomes a minus, and a minus becomes a plus. Then you just add them up like you did before. Seriously, don't forget that sign change. It's the #1 place people make mistakes.
Okay, we've totally got the hang of combining terms. So for our final section, it's time to level up. Let's talk multiplication and division. These are the operations that are going to let us build some way more complex and powerful stuff. Okay, the rule for multiplying these things is actually pretty simple, but it is super powerful. Every term in the first expression has to multiply every term in the second one. You can see what's happening here, right? The first term has to shake hands or multiply with every term in the second set. Then, the next term does the exact same thing. This makes sure that every single piece interacts with every other piece.
So what about division? Specifically, dividing by just a single term, a monomial? Well, this process is actually kind of beautiful. Instead of looking at it as one giant, scary fraction, you just split it up. You divide each piece on top by the thing on the bottom, one at a time. It's a classic strategy. Turn one big problem into a few small, easy ones.
All right, let's do a quick recap of the awesome toolkit we've just put together. We started with our most basic pieces, constants and variables. We combined them into terms, then we linked those terms together to make expressions. We learned that like terms are the absolute key to adding and subtracting, and that distribution is the name of the game for multiplication. These are your core tools, the fundamentals of algebra.
You know, we started this whole thing by talking about algebra like it was some kind of secret code. Well, guess what? It's not a secret anymore. It's a language, a powerful language for describing the world and solving problems. Now that you've got the basics down, the only real question left is, what amazing problems are you going to solve with it?